Here we are at example 3 in the corollary dealing with computing some limits. Now, if we're having the limit as x is approaching infinity of x raised to the nth power, what we're going to be looking at are things where that nth degree is maybe even and odd. So over here we're going to have it be an even power. So in other words, these are like your x squareds, x to the fourths, things like that, x to the 6, x to the 8. And we know that from algebra 2 that those are just parabolas that open up or down depending on that leading coefficient, but pretty much just this U type of shape. Well, then the limit as x goes to infinity of x raised to the nth power that's even is going to come out to be positive infinity, because as you go outwards for x, we see that our limits are going up and up and up and up forever and ever. Now let's look at and go ahead and see the limit as x approaches negative infinity. So pretty much just going the opposite way of our x to the nth power. Well, here, as we go outwards towards negative infinity for x's, we see that our limits are approaching a positive infinity as well. Now let's go ahead though and see what would happen if maybe we had an nth degree that was that was odd. So these ones will be n is odd. Anytime that we have an odd power like this, it's kind of similar to the tangent function, but we see something that has this S shape. Now, again, just looking at the limit as x approaches infinity, positive infinity, of our x raised to the nth power. So these are like x cubed, x to the fifth, x to the seventh, things like that. We end up then, as you go outwards towards infinity for x, it is going upwards towards positive infinity for that limit. Likewise, taking the limit as x approaches negative infinity of our x to the nth power. So as we go outwards to the left for x, we are going down toward negative infinity. Now these are actually really handy to think about as you're doing limits, these two kind of like basic parent functions and how they behave as you're looking at things going towards infinity or negative infinity. Now let's go ahead and look at example 3 to help illustrate these points. Now when we're looking at example 3a, we're seeing that we have the limit as x is going to infinity of this polynomial function. And when we're describing polynomial functions, the thing that describe the end behavior are actually your degree. And so we notice that we have x to the fourth, this would be our highest degree, and as a result, this guy in front is going to be the most important piece that we're looking at. So if you were to like graph this is just going to be it's not even going to be this function, but if you were to do a graph, and it has this other stuff, negative 3x cubed plus 2x minus 4, but what's going on is that's actually kind of just the curvature and the ups and downs of your graph. Whereas the end behavior things, like where these arrows are pointing to, that's going to be determined by your degree from your actual polynomial. So we notice that this guy is even nth degree. And because it's opening upwards, because this coefficient in front is positive, it's going to be opening upwards. So we do actually see something like this. And the limit then, as x is going to infinity, is going to go to positive infinity. So again, we really don't even care too much about all this other stuff. We're really just looking and seeing the highest degree and what the end behavior is like as a result. So because it was even, we knew that it had to be a U shape. And because the leading coefficient was positive, it was 1, it had to open up like this. So as x went out towards infinity, we had to go for that limit being upwards towards positive infinity. Now, likewise, we really only care about this degree and leading coefficient for the first one. Don't really care about this other stuff. Now, as x goes towards negative infinity, then that limit would be approaching positive infinity. So again, that is example 3. Really, you're just looking and you're seeing what are the degrees and what's the leading coefficient, because that's going to determine your limits then. But again, though, that is example 3 from our 1.5 number 2 set of notes.